In this session, we'll talk about the condition for the line y is equal to mx plus c to be a tangent to the circle x squared plus y squared is equal to a squared. What does it mean? The circle at the origin is given as x squared plus y squared is equal to a squared. Origin sense, the center is nothing but 0, 0 or g is equal to 0 or f is equal to 0. Now, what is that you have to know before we derive this? We just have to know how to find the perpendicular distance between a point x1, y1 and the line ax plus by plus c. Well, let this be the point x1, y1 and let this be the line ax plus by plus c is equal to 0. Now, from your first POC we know that perpendicular distance is given as modulus of ax1 plus by1 plus c divided by square root of a squared plus b squared, where x1 and y1 is this point. And what am I getting out of this is this distance, perpendicular distance, let us say CP. Okay, to understand this better, let us consider an example. Let us say 1, 2 is a point and the line is 3x plus 4y plus 9 is equal to 0. How do I use this information in this formula? Look at this. This is my point, x1, y1, and I'm supposed to find out this distance. Let us say CP again. So perpendicular distance is given as modulus of, here the line is ax1 plus by1 plus c. So I have to take the same line here, where a is 3, b is 4 and c is 9. Let me write 3. And instead of x, I'll write this point, that is 1. Plus 4 into what is y? Y is 2. Plus 9 divided by square root of a squared and b squared is nothing but 3 squared and 4 squared. Okay? So that is 3 squared plus 4 squared. So what do you get here? CP is equal to, it is 3 in 1, 3 plus 8 plus 9 divided by square root of 25. That gives you 20 by 5. That is equal to 4. So what is this 4? This 4 is nothing but the length of the line CP. Let us say it is 1, 2, 3 and 4. This length is equal to 4. Now, how do I use this information to derive it? Let's go back to this. What is given to me? Given is the line y is equal to mx plus c. Now, can I write this line in the more general form? Y is equal to mx plus c can also be written as, if I put y on the other side, mx minus y plus c is equal to 0. Isn't it? Now, where? If I compare this with the general equation ax plus by plus c is equal to 0, I can say that a is equal to m, b is equal to minus 1, c is equal to c. Very simple. Now, I can see the diagram. I can say that CP is the perpendicular distance between this point and this line. So can I write CP is equal to A also? Because A is that distance, that is radius. How will I find CP? I can use that formula to find the distance between point and line. So it can go like CP can be written as this line, that is mx1 plus y1, minus y1 plus c divided by square root of, where a squared and b squared are nothing but what? What is a? M squared plus b squared is minus 1 squared. Look at this. Now what is x1 and y1? Come back to this. This is the line and x1, y1 is nothing but this point, 0 and 0. Why? Because the point is on the origin. Okay. If I substitute 0 and 0 here, what do I get? I'll get m into 0 minus 0 plus c divided by square root of m squared plus 1 square modulus, and that should be equal to the radius, that is a. Now, if I solve this thing, m into 0 is 0, 0 is 0 itself, and c divided by square root of m squared plus 1 is equal to a. If I remove the modulus, I can add plus or minus on the other side, that is square root of m squared plus 1 is equal to plus or minus of a. Look at this. Now I need to square on both the sides. Let's say, so this. If I square on both sides, I get c squared by square root of m squared plus 1 is equal to a squared whole square here. If I square this, square and the square would go, and c squared is equal to m squared plus 1 is equal to a squared. Cross multiply this, you'll get c squared is equal to a squared into m squared plus 1. Okay, this would be the condition for the line y is equal to mx plus c to be a tangent to the circle x squared plus y squared is equal to a squared. This is one of the important derivations for 3 marks. So take your time, do it once before we proceed. Okay.